Okay, it is now 3 o'clock Central European time. So we will start out this webinar. First of all, of course, welcome. We are very excited that you could all join our webinar here hosted by Danfoss high pressure pumps. Before we start, we just have a few practical information. As there are more callers on the line, you have been muted by default. If you have any questions during the webinar, which we hope you do, then please add them or write them in as you see on your screen here. And then we will answer them as best as possible. Also important to inform here is that we are recording this session and we will be distributing this recording after our webinar. Okay, but let's get started with the actual presentation. So what we will be talking about today, just need the slide to change, is firefighting systems using high pressure water mist. And as I mentioned, we come from Danfoss high pressure pumps. I will be presenting the first part of this webinar where we talk about the high pressure water mist technology and some of its benefits. We talk about some of the products that we can offer into this segment. And then at the end, I have my two colleagues with me, both having a case to present about the use of our products in different kinds of firefighting applications. Good. So as you see here, Danfoss high pressure pumps, we provide solutions for a number of different segments. Today, of course, we are talking about firefighting. And here we offer both our high pressure pumps, the so-called PAH pumps. We also have high pressure valves, different kinds of valves actually, which we will come to later. And we also have nozzles, high pressure nozzles, individual nozzles, not nozzle heads. So let's have a closer look at firefighting. So overall, you can say that in order to have a fire, you need three elements, and that is represented here in the famous fire triangle. You can remove one of the elements and you will kill the fire. You can, for instance, remove the heat. That's what you do if you use normal or traditional low pressure sprinkler systems, and then you would remove the heat. You can also remove the oxygen. That is, for instance, what you do when you use gas to extinguish the fire, or you can work on removing both of these two elements, and that's actually what is happening when you are using the high pressure water mist technology. And that's also why it's a highly effective and fast way to extinguish fires. If we then take a closer look at high pressure water mist, some of the advantages is, as mentioned, that this is a very effective way to combat fires, as it is working on both elements, the heat and the oxygen. And the water that is being sprayed is turning into a mist due to the high pressure at the nozzles, and it means that it will have a much higher cooling effect, up to 7 times higher than that compared to normal sprinklers. So when you extinguish the fire is typically happening much faster. And on top of this, on top of the cooling effect, the high pressure water mist also blocks the oxygen around the fire, like almost like a carpet. So the fire cannot get any oxygen, and therefore is extinguished. Yes. So therefore, it's a very effective way to turn out a fire. If we move ahead, another benefit is that you need much less water to actually extinguish fires. In some cases, up to 90% less water, because it's so effective and because it's turned into a mist. So this also means that when you have less water, you also have less damage afterwards, meaning also your reconstruction of your building will typically be faster as there is less damage. In some cases, even if we are talking about traditional firefighting systems that pours out a lot of water, the reconstruction can be, much larger or much more costly than the damages by the fire itself. But this is not normally the case for high pressure water mist, due to the very low amount of water used. Yes, and if you take the next slide, yes. So as less water is needed, also smaller water tanks are needed, and fewer tanks. And if we look at, for instance, our piping, well, piping is smaller. Again, less water is needed. Piping does not need to be very big in size. And there are also other components where you can save money. And in total, it just makes it or gives it a good or attractive capex. Actually, we have one case study coming up, our second case study that you will see a bit later. Here we are also diving into this capex topic. Yeah, stay tuned. We have a very nice example for you there. How our customer was able to make a very efficient firefighting system, but also making it very attractive on the capex side. Again, very little water is used, as mentioned. That means also smaller water tanks are needed. And in this case, if you look on the drawing here on the left, if you're talking about a high-rise building, you don't need water tanks or pump units going up on the different floors in that building, and you don't need a big water reservoir on the top of your building. And all in all, this just means that this space that you would normally use for water tanks and for the firefighting system, you can free that up and use for other purposes. And in some cases, this can be very attractive to end customers. This is actually also one of the cases that we have brought today where that is the case. Okay, if we turn the slide. But I'll move ahead. So if we move forward and then look at what kind of products do we offer here at Danfoss high pressure pumps. I just have an echo on the line right now, so I'm a little bit okay, I'll try and move ahead. As you see here, this is an example of a firefighting skid, as it could look like. The kind of products we offer here are marked with the different position numbers. Position 1 and 2 are our PAH pumps.
I'm sorry to interrupt, Kent. Indeed, we are capturing quite a lot of echo.
Yes, I get that also on my microphone or on in my headset.
Can we try to Can we try to maybe mute and mute on the PC itself? Can this be an issue? Or in the meeting room, you know?
Yeah. Just a second.
Sorry for the participants. And in the meantime, we could actually, while we are fixing this, we could actually maybe, is it okay with you that we will launch poll, the question that we have, while you're fixing the audio?
Unmute.
Okay, so now you are unmuted, Karen.
Yeah, yeah. Yes, and I hope you can hear me. We have a question for you, which will be shown on the screen now.
Yes, launched. Would you like to read the question aloud, just for our panelists to be aware?
It's not shown on the screen?
Yes, it is. Are you familiar with the high pressure PAH pump from Danfoss? And we already have many responders. So just let's allow 30 seconds before we share the results of the poll. Okay, just a few seconds more before we close. Some interesting dynamics. We will share results in a second. So here are the results. And it's 52% who selected answer yes, they are aware, and 48% said that they are not aware. So Kent and Karen, would you like to comment on that statistics?
Yes, that looks very interesting. I hope you can hear me now. Yeah, I'm gonna mute.
Exactly. I think right now it would be better if you fit it that way and go back on maybe Karen's audio. Because you are muted right now. Karen,
yes,
can
okay.
we please maybe? Okay, yes.
I have unmuted my own microphone. I just have an echo then. Because I can hear Karen's
Okay,
sound.
Apologies for that. Can we please agree that you mute your mic and then go back to Karen's microphone? We could actually hear you without echo a moment ago.
Yeah, I'll try to do that then.
This works now. Super. Thank you. Let's proceed.
Perfect. Thanks, and sorry for the technical issues. Let's move ahead. Yes, it looks very interesting to have both people that seems to know our pumps and business quite well, but also have that many new people here on today. That's very exciting. And therefore, it also makes good sense that we now move ahead and talk about the products that we have. I will just take off my own headset as well because I still have an echo. Okay, so as you see here on the screen, this is a schematic of how a firefighting skid could look like. We have on the different position numbers the key components that Danfoss high pressure pumps can offer. And if we take them one by one, the first two ones are our PAH pumps. They're used as the main pumps and also as backup or redundancy pump. That would be the same pump size typically. We have also smaller pumps in the same pump family. They are used as a jockey pump or pilot pump. It has different names, but means the same to keep a constant pressure in the line, also when the firefighting system is not activated. And then finally here on the pump skid, we have different kinds of valves, among other pressure relief valves, or VRH, which will make sure that system pressure does not exceed certain limits, and in case it will, then it will relieve the water back to the tank via the filter. And also check valves to make sure that there is no flow running back into the pumps. In addition to this, what is not shown here on the pump skid, we have our VDHT valves, which are solenoid directional valves or on-off valves. They are used for as part of section valves. So to control the different zones in an application. All of these we have more information about on the coming slides. So if we split flip the slide, then we can move ahead. First of all, we have our PAH high pressure pumps, and they are actual piston pumps built on the positive displacement technology. The amount of flow that they provide are directly proportional to the speed of the shaft. So the more rotations the shaft, the more flow they provide. We have them in a number of different sizes. You can say, if you look at the table below, the first two pump frame sizes are typically used for pilot and jockey pumps, whereas the last two ones on the right, they are used typically as main pumps. And they range from flows from 2 liters a minute to almost 147. Yes. Also worth mentioning is that these pumps here, they can be sold with marine certification. Another point to mention is a recent product update that we've made on the PAH 100, so on the pump family to the far right. we have released our pH 100 up to also 160 bar for 500 hours. So which is ideal for firefighting applications, or typically more than enough hours for firefighting applications. Besides this, worth mentioning another relatively new thing is also that we have released them up to 2400 RPM, so they can be speeded up for also 500 hours. So this is again something that is very relevant within firefighting applications, in case you need a higher flow. Great, and finally they can be bored in both clockwise and counterclockwise variants. If we move ahead to the next slide. These pumps are highly reliable. They are made in stainless steel, and they are all tested, each and every single one of them, before they leave the factory. Especially within firefighting, having a reliable pump is, of course, of high importance. It's not so much the operating hours, but it definitely needs to operate when needed. Also, we have a quite extensive quality system in-house here. We are what is called IATF certified, which is an automotive quality standard. So yeah, we are following very strict quality standards in this case here. Besides that, the pumps, they don't need a lot of maintenance. There are no oil in them, making, they don't need any oil service. And they can also operate for a long time, up to 8,000 hours in between service inspections. Unless, of course, as I just mentioned, for those cases where they are released to 500 hours in special cases. They are very compact and lightweight, making them easy to install and to fit into even tight spaces also. And there are no need for belt drives or anything of that like. Again, making it a compact solution. Also, the high number of pistons inside the pump makes them or gives them a very low pulsation. So there are no needs for, or typically no needs for pulsation dampeners either. Good. If we then
Yes. I think before we move ahead with the valves, we have a question more coming up.
Yes, launching the poll once again.
Yes.
Here we go. Are you familiar with the high pressure valves from Danfoss? Please select one response, yes or no. Oh, very nice speed. We already have almost half of our audience responded. Let's see. Ten seconds more before we close. All right, so sharing the results. So we have 63% who said yes, familiar with high pressure valves from Danfoss, and 38% said no. So would you like to comment?
Yes, it's interesting to see that actually more people seem to know our valves here than the pumps, but we also have very nice valves, absolutely. So I'm pleased to see that. If we move ahead to the slide about the valves, yes, here we go. As mentioned, we have different kinds of valves. One of them is the VDHT solenoid directional valves. They are on-off valves, and they are operated by an electric signal that activates the valve, either opens or closes it. And we have them in also a number of sizes ranging from, as you see in the table below, 2 liters a minute up to 150 liters, equal to 40 gallons a minute. Also for these valves, we offer marine certification. If you are, or if you have a marine application. Yes, another part of the VDHT program is that some of them we offer with manual bypass. So they have both the ability to open and close with the electrical activation, but they can also be operated manually with a handle, so they can you can force them open. This is actually the picture on your top left. If we move ahead, then let's look at some of the benefits we have for these valves. Good. Again, these are stainless steel valves, and they are also 100% tested from factory before leaving. So they are highly reliable and have a long lifetime. Also, they can be serviced without demounting them from the pipeline. So that makes, in case service is needed, it makes it very easy to do. And also they are very compact, making them fit into also very, very tight spaces. And at the same time, even though they are small and compact, they have a very high CV value, meaning that they provide a lot of flow with a limited pressure drop. So these are some of the main benefits that these valves can provide. If we move ahead, we have, as mentioned, marine certification on our valves or on our VDHT valves, and also on our pumps. Some we have already, and some can be requested. Having approvals on the product is typically not something that we see within the high pressure water mist market. There we are talking about system approvals, and this is also the case here, of course. But for marine, there are additional certifications, and there we are also able to provide this. Just needs to be requested then before ordering. Let's move ahead. Finally, we have our relief valves. As mentioned, they make sure that the system pressure does not exceed certain limits, and if it does, then they open up and relieve some of the water back into either a drain or back to the tank via the filter. And we have them also in different sizes, ranging from 5 liters a minute up to 120 liters a minute. And actually for firefighting, we have a dedicated version called the VRH 120F. The special thing or unique thing about that valve is that it opens and closes, more or less right away. Whereas the other valves, they open and close over a longer time. Then we have optimized the VRH 120F for firefighting. And the technical specifications are the same as listed here. Yeah. Okay, and the last valve to be shown here today are our check valves. They also called non-return valves. They make sure that flow is only in one direction and make sure that flow does not flow back to the pump on the high pressure side. Yes, I think that was it. I hope I did not speed up too much here in the end. Before we come to our cases, are there any questions that?
Yes, I got a question here. There was one of the participants asking, can we buy a whole water mist system from you?
Okay. Well, thank you for the question. No, not from Danfoss high pressure pumps. We are providing components to a range of different customers who would then typically build the whole system. So we don't provide systems, we provide components. I know that some people, they might confuse this because we have a sister company within Danfoss that also provides systems. But Danfoss is a very large company. I think we are more than 27,000 employees, and there are a lot of businesses operating within Danfoss on an independent setup. So we have our own business, and we have arm's length relation to our sister company that makes systems. We have different CEOs and leadership teams, and they are treated just the same way as any other customer of ours. So, but just to sum up, Danfoss high pressure pumps, we provide pumps and valves and individual nozzles. Okay. Yeah. Okay, but then
let's move on to some.
Yes, let's move on to the cases. We have, many years of experience with firefighting, and we have already a lot of products installed in various applications around the world. It could be buildings, it could be different kinds of marine applications, and it could be also infrastructure projects where we have our products installed. And if we jump to the first case, we have today brought a case about firefighting on board trains, and I will hand over them to Claudio for presenting that case.
Hello,
Yeah.
Can you hear me?
Yes, we hear you well.
Good. Thanks Kent, a lot for your presentation. I will show a real case and explain what Kent has shown us before on a real situation that we've been studying first and then realizing and see what we achieved. As you can see, the requirement from one of our customers, it was about the 2018, was to collaborate in projecting a new system of firefighting located on board of high-speed trains. As you understand, there were many challenges because the location of a train is not a simple place where locate a firefighting system. The firefighting system had to be, of course, effective, but also simple in realization and compact, because every firefighting system had to be independent on each car. So the realization was from the beginning very important how to design this system, considering that the commercial space on each car was very important for the end user. And so the compactness of the system was absolutely needed. One other challenge or requirement from the customer was that as every firefighting system was working independently, the water would not have damaged the furniture and the electrical component of each car. This was in case of a very small fire. They didn't want to destroy the entire car or the entire train, of course, due to the cost of the train. Regarding the space, but also the weight that the train was able to carry on, was required to don't have large water tank. Water tank were thinking to be located one small water tank on each car, and not one, of course, single huge water tank for the entire train. Can we move to the second slide? Okay, here we see the solution. The solution that we found was a high-pressure water mist system activated by nitrogen. What does it mean? Kent has already shown us the meaning of a high-pressure system and why a high-pressure system is used. The high-pressure system has two effects. The first is the cooling effect, meaning the temperature inside, in this case, the car of the train, drops down dramatically in a short period, and this helps to extinguish the fire. The second is the segregation of the oxygen. In fact, when we spray water at high pressure, the drops that comes out from the nozzles are very, very small. And each of these very small drops segregate oxygen. And without oxygen, the fire extinguishes. This fog that we create inside the car is not danger for the electrical component of the train and doesn't destroy the furniture of the train. On the bottom of this slide, we can see an example of a car, of a train. How the system in reality works. We see different letters in the drawing. The letters show where can be located the sensors of the firefighting system. Basically, when each sensor detects a fire, the sensor sends a signal to the valve. The valve open and allow the water going through the pipes, through the valve, to the nozzle. It means that when the valves are closed, there is no water between the system and the nozzle. This is very important, and this is why we call this system dry system, because in case of incident, not fire, but incident, or in case of alteration of the system, there is no water in the piping, so there is no risk of incidental flooding of the car. As we can see, the water under pressure, in this case, was not activated by pumps, but by a nitrogen tank that push under pressure the water. What does it mean, high pressure? Normally, we work over the 60 bar. It depends on the nozzle type. It depends on the type of fog that the client wants and the type of application. Can we go with the next slide? Okay. The result is that together with the client, we select the VDHT 3/8-inch normally closed valve. This is a very, very compact valve. It's completely built in stainless steel IEC 304. Can work with a pressure up to 160 bar and a flow of 30 liter per minute. Why the customer like this valve? The valve is very simple to use. It's extremely reliable. Consider that we test every single valve before shipping out from our warehouse. Each valve is work to achieve at least a lifetime of 500,000 activation. And this was extremely important for the reliability of the system. The valves were combined with a very small tank, only a 60 liters tank, that is enough to extinguish a fire on the entire car of the train. This is it on my side. If there will be questions.
Yes, there is one question here. The question is this a common application?
This is, through our experience, is becoming more and more common. This for us was the first large project where we were involved on train. But we know that we have received other requests from all around the world, and it's something coming very, very quickly. We believe that it will be a request for every new train worldwide. So more and more we will see these systems.
Okay, I think that was the only question. Thank you very much, Claudio.
Thank you.
Let's move on to you, Roman. You also have a very exciting case story to present.
Okay. Good afternoon, everyone. Do you hear me? Do you see me? Good afternoon, everyone.
Yes, yes, all good, all good.
Okay, thank you. So let me introduce with our case story. Sorry, my name is Roman. I'm key account manager in the Moscow branch office in Russia. Let me introduce with our case story, which we have here. In Russia, we have closely cooperates with Foxstream company with the registered trademark of the same name. This is the leader in innovative technologies in the local market firefighting system. This company has extensive experience in the design and production of the firefighting systems, as well as the provision of comprehensive services for the installation and maintenance of implemented objects. The Academic Business Center is an award-winning new building with a total height of 92 meters and 7,000 square meters, spread over 14 stories above the ground and the 2 underground parking levels. There are some shops, medical center, and the 2-level restaurant in the steel bite here, and 20 floors up. Foxstream firefighting system protected the entire area of the facility, including the office parts and the underground parking. Our customers' system totally covers 200% of this area, this facility, and is organized according to the principle of 2 zones. One station with the one station with the PAH 80 pumps provide protection only for parking lots for 520 cars, and another station for the residential office part. And due to the fact that this object is located in the respectable area of the Moscow city, not in Danfoss, there is a high rental rate of commercial space and the high cost of water supply. In this case, traditional sprinkler systems had an extremely high cost during calculating the cost and the design stage. So the challenge was design a firefighting system of the utmost reliability that requires as little space as possible with the lowest water consumption. Next slide, please. Okay, here you can see the implementation of the system based on our equipment. I mean, our pumps. You can see around parking floors has 4+2 PHT 80 pumps, as I said, and you can see all these operating characters. So besides relief and check wells, these system used frequency converters, sensor and pressure sensor, pressure relays from Danfoss product line. It means we can provide an almost complete supply set of our equipment for design purpose, a system from the one supplier. In some cases, this can be important argument in favor of choosing Danfoss product. Next slide, please. Well, at once again, I want to pay your attention for the fact that at the design stage, that comparison was made with the sprinkler system, which at the first stage was designed until the moment the customer abandoned it in favor of Foxstream system. This economic benefit was obtained by freeing a large part of the facility area. It's around 180 square meters from the fire tanks with water of the classic sprinkler firefighting system, which has designed the facility before the Foxstream appeared. To store the estimated firefighting water supply, it was 380 cubic meters. The Protex was provided to tanks of the 180 cubic meters each. For comparison, the entire Foxstream system at the facility took only 9 square meters only. Just imagine 9 square meters only versus sprinkler system. Further, the freed up area was multiplied by the market value per square meter. The same effect of significant saving was achieved by reducing consumption water at 5 and or 10 times, and achieved by some innovative installation methods by Foxstream engineers, eliminating the human factor and significantly increasing reliability. So the results of all these works, its annual economic effect around 1,000 feet, 35,000 euro annual economic effect. So in conclusion, I want to say, if you are interested in this case, you can contact me or with my colleagues, and I will be happy to share more information with you. Thank you for your attention. Any question? Hello? Anybody here?
No, there is actually one question we got, Roman, and the question was, why do they need one system for the parking floors and then one for the floors above?
Good question, thank you. As I said, Foxstream firefighting system was equipped with the two pumping stations, one of the underground parking and another one in the above ground part. The difference is consumption is explained by the increasing consumption of the splinters used in the parking lot, which belongs to different category of the fire load, and the presence of deluge curtain there. What is a fire load? I try to explain. That is, the system should be able to fight with fire more quickly in those places where we have objects that have the probability of explosion and the rapid spread of the flame. For example, in our case, there are cars with the fuel tanks, so we need to split the system and have absolutely completed system for this building. Hope you understand me.
Thank you so much. There was another question, and I think that is for you, Kent, that was early on. The question is if there is a pressure relief valve in each pump, or is there one pressure relief for all the pumps, or for in each pump? Does that make sense? Sorry.
Yeah. I mean, if we have a customer application where we are using more of our pumps, I'll turn on the camera also. Then what we recommend is, if possible, to use one relief valve. That would be the ideal case, because then we avoid having more relief valves that needs to be set exactly the same. So it's not just one of them that opens at a given pressure and the other one opens at another pressure. So therefore, one relief valve per system, if possible. With that being said, I would also say that if you have any questions regarding PNID schematics, we would also offer to have a look at that, to give our inputs on that. Yeah.
Yeah, I think that's it. I don't see
Karen,
any more questions.
please.
Yes.
Yes, try to have a look. I think we just received one more question. I hope we can still respond before the end of the webinar. Could you see it right now in the system?
No, I don't see it.
Can
you read it out?
Yes, absolutely. So high pressure mist firefighting seems so much better. Do you think it will eventually replace low pressure systems?
I don't know if I should answer, but I would say I don't see that it will completely replace sprinklers. I mean, there are some clear advantages, but there are also some limitations. I mean, to the high pressure water mist systems, that it should be within confined spaces, indoor, and that it's sensitive to windy areas, locations, that kind of thing.
Okay,
But
thank you.
On the broad picture, I would say, yes, it's a very good alternative.
Good. We also get feedback about previous answers that it sounds great. Super.
Okay.
Nice. If there are no more questions coming in, then yeah, I would like to say thank you very much for attending this webinar. I hope you enjoyed it and that you got the information that you were hoping for. You are always welcome to contact any of us, and we would be happy to answer any further questions that might be popping up a bit later. So please just reach out to us. And with that being said, yeah, enjoy the rest of your day. Thank you.
Thank you.
Thank you very much, and goodbye.
Thank you.
Bye.